In this video, we're going to take a brief tour of the terrestrial planets at some of their surface features and talk about the difference between impact craters and volcanic craters. So some images from the moon of impact craters. What would you see as a clue that these might be impact craters? Well, we have a raised rim. So the impact occurs. It moves material away from the impact center towards the outside and leaves a raised rim, but the floor is down below the level of the surface, and there may be a central peak at the center of the crater, or there's been kind of a rebound when the large object plowed into the crust of the moon. And then there was kind of a springy action of material bouncing back up. But raised rim is a key indicator. It's going to distinguish the impact craters from volcanoes. We have a deep floor for the impact craters. For the case of the volcanic craters, we'll have an overall net material above the average level of the surface. They'll have kind of a dome, and at the top of the dome, when the lava collapses, cools back down, there can be a crater at the top of that volcanic dome. So we'll take a look at some of our surfaces here. So on Mercury, there are also craters. Mercury has been struck very often by large objects, and you can see again rays of material where material has been blasted out and tracks away from the very large craters. The craters come in all sizes. We do observe that there's not much in the way of large craters being produced in recent history, and age can be estimated by counting craters per area. Where there are more craters per area, it's older material. And we can look for craters on top of other craters and date the craters that way. So the very largest craters are very, very old, and they don't seem to be in recent history, hundreds of millions of years, there don't seem to have been very large impacts anymore. And probably it's because those large bodies causing these very large craters have all been kind of swept up by the planets. So there are no longer as many very large bodies in orbits that cross the orbits of the terrestrial planets. There are some large bodies in the asteroid belt between Mars and Jupiter, but not so many that have kind of strange orbits, more eccentric orbits that very elliptical shape instead of the nearly circular for the planets, such that these large bodies would cross the planet's orbits. There are still small impacts that are occurring, and new craters have been found on the moon, on Mars, for example. But we do have some interest in these impacts and the history of our solar system. There were many more impacts per year in the early solar system, not so many impacts per year in the current solar system. But Mercury preserves these craters. Mercury has almost zero atmosphere, so there's no erosion that takes place, and currently there's no lava being released on the surface of Mercury, so the craters are preserved. For Venus, we have to use radar to penetrate the thick clouds to observe craters, but again, you can see these circular shapes. There's good evidence for large craters on Venus. There are not so many small craters on Venus, as objects that cause small craters are small objects, and they have a difficult time making it through the thick atmosphere of Venus before being burned up. But there are large craters on Venus. There are also volcanoes on Venus, and the radar images, some of them have shown a change in the slope of the volcanoes. So quite possible that Venus still has active volcanoes. It's inferred from radar. It's also inferred from some of the probes in the past found a change in the amount of volcanic type gases in the atmosphere of Venus. I'll just put it that way instead of saying specific gases. But there's some evidence from radar, some evidence from composition of the atmosphere that volcanoes may still be in business on Venus. On the Earth, here's a crater in northern Arizona, the Baringer crater. I think it's about 50,000 years old, if memory serves me right, but caused by a large piece of rock coming in and blasting out. You can see here more clearly that the floor of the crater is down below the average terrain level, and we have a buildup of this rim of the crater, and there has been debris found around the crater from the impact. The Earth does not have a great number of craters to visit. On the Earth, there is erosion, and we have a situation where this weathering destroys the evidence of the crater. We have vegetation, and we have lava that occasionally will recoat the surface of the Earth and destroy the old craters. So not quite as many. Moon, Mercury are better. For Mars, we also have craters that are visible in the images to Mars. If you look around, you can see various circles that are in the image here. These are larger ones that are visible in this image, and more detailed photographs of the surface of Mars show craters as well. This particular slide shows volcanoes as well, these dark spots over here. This is raised up above the average terrain level, and looking at a volcano. The Gale Crater that the Curiosity rover landed in 2012, and has been, this is 2014 for this recording, that rover doing great work and probing the environment in that crater, but 90 miles across. If that hit someplace near us, this size of rock, that would not be a good situation. But Mars has craters, both volcanic at the top of old volcanic domes and craters caused by impact rocks. So on Mars, there are some orbiting spacecraft that photograph the surface of Mars. So here we have before and after. Here you can identify the craters here easily, that we're looking at the same spot on the ground. And then in 2008, a photograph showed a recent crater, and the rock had impacted Mars and sprayed out debris, kind of the ray pattern that we talk about from Mars. This will get eroded a little bit because Mars does have dust storms that will kind of fill in and sandblast these rays. That you can see the craters do survive. Mars has no rain at the present time, so that type of weathering, water flow doesn't destroy the craters as fast. There are also, probably should mention this, meteorites have been found on Mars by the rovers. So we'll talk more about that when we talk about Mars. The largest volcano in the solar system, Olympus Mons, is on Mars, and we're looking down at the top here. These sides, these edges here, are cliffs. The whole volcano is a shield volcano where the lava came up in one spot for a long time, similar to the Hawaiian Islands, build up a large mountain of lava. When it cooled off, then we get the craters at the top as the lava sinks back into the dome of the volcano. The volcanoes, they're up above the average surface level, and then we get these craters at the top from lava that cools off. But astronomers think that the volcanoes had a big effect on the atmosphere of Mars in the past. The volcanoes would release a lot of gases from the interior of the planet, Mars, Venus, Earth, and most likely Mars had a thicker atmosphere in the past. And it's currently being studied on why Mars lost its atmosphere. Again, we'll talk more about that when we talk about Mars. So we reached the end. Why didn't I go into Jupiter and Saturn and Uranus and Neptune and talk about craters seen on those planets? Gas giant planets. And so the rock plows into the gas and disturbs the gas, and there have been impacts of comet debris observed on Jupiter. But the atmosphere recovers in not too long of a time, and you can't tell that an impact had occurred. So we don't see a solid surface when we look at the gas giant planets, so there's nothing there to retain the impact shape. So the cratering that you saw in these slides from the terrestrial planets, where we do have solid surface to retain the impact information, and just a little taste of things to come as we will study these more as we look in the planets in detail. This is the end.